Hey, what's going on, guys? Again here. In this video we're going to learn how to convert x86 and/or and Xor instructions to machine codes using hand assembly techniques. So the very first case, if we want to bitwise and a X register with the constant value, also known as the immediate data. For this purpose we have the special opcode which is 25 in hexadecimal. And then we just need to encode the data, and initially we have the data in the big endian order, but we need to convert this to the little endian. Okay, so this is going to be the value for the first instruction, and I'm using NASM to verify myself. So we have 255588, which is correct. Great. So let's move further on. The next scenario, we want to bitwise and the DH register with immediate data, and this byte 05. Okay, so for this purpose we go in for and this is the opcode. Okay, this is the opcode, and now the instruction format could be taken from here. All right, and now you see this question marks. This means that we need to look at this table and find and here, and we want to replace the question mark with this value 0, with this value 100, right? So we no longer need this square brackets here. Now, how to decode this one? So this should be 4 bits eventually. This should be 4 bits eventually. So W is going to be either 1 if we're dealing with a 16-bit register, or 0 if we're dealing with the 8-bit register. DH is the 8-bit register, hence this is going to be equal to 0, and this would be represented as 3 zeros, right? So now this is hexadecimal, and now we need to encode the register. So DH is going to be DH 110 110 110. So this is binary, this is binary, and this is binary, and the data is 05 hexadecimal. Okay, so now to convert this entire thing to hexadecimal instruction, to machine code in hexadecimal, we can say 80E605. So let's verify if this is the case actually. So 80E605, which is the case. Great. So the next thing we want to bitwise and two registers. All right. So first to get the opcode. So line number 3. So the opcode is this one. All right. So let's take the opcode. Then the instruction format we can grab from here. Okay. So first, we have the source register, which is CX. So the code for CX is 001. So 001, and then the destination register goes here. So DX 010, and now to decode this. So 3 zeros, and W is equal to 1 because DX and CX are 16-bit registers. So 2H, now this is binary, this is binary, and this is binary, and eventually we have 2, 1, C, A. Okay, so let's check if this is really the case. 2, 1, C, A, which is the case. Great, so we can move on. And the next thing we want to bitwise and the word at the memory. So these 2 bytes, the word with whatever we have in BX. So let's grab the opcode for that. So the opcode is encoded the same way still, right? And here is the instruction format. So we have 00 is mode, which is telling us that we're dealing with the memory. So here we dealt with the registers, here we're dealing with the memory, and this code tells us that we're dealing with the direct memory. So we can use the address from what we got right over in here. So 01 F0, but bear in mind the fact that just like with the value, we have this in the big endian, so we need to convert this to the little endian like this. This is going to be hexadecimal, and the register BX is BX011, okay, 011, and here 000 and 1 because BX is 16-bit. So 2H, then binary here, and eventually we have 211EF001. So let's check this out. 211EF001, which is correct. Great. So we move further on. Now we want to compare. Now we want to bitwise and DH with a value with a byte in the memory. So for this sort of a thing, we take this opcode, okay, and the instruction format. So line 5 here. This is the instruction format. It's the same as for the previous one. Okay, so address is F001. The register is DH, which is 110. Okay, 110. DH 110, right? Okay, now this, so 1 to binary 001, and this is going to be 0 because DH is 8-bit register. So when we have hexadecimal, binary, and hexadecimal here. So this would be 2, 2, 3, 6, F001. Okay, let's check this out. 2236 F001, which is correct. Okay. And now we're moving to the OR instruction. So it's really similar to what we did so far. So let's start with a special case for AX. So this, we have this opcode 0D. So we have 0D, and then the value in little endian, this is going to be 5588. So this should be 0D5588, which it is. Okay. And now bitwise or DH with the immediate data 5. Okay, so this is the opcode, right? Paste, and the format is here, and question mark for OR is 001. All right, so here we have 001. Okay, now the register is DH, which is 001 as well. 001. The data is 05 hexadecimal, and now the opcode is 000 and 0 because the DH is 8-bit register. So this is hexadecimal, this is binary, this is binary, this is binary, and eventually we have 8, 0, C, E, 05. So let's check this out. Okay, 8 ECE05, which is correct. Great. So now bitwise or DX and CX registers. Okay, so or this is the opcode and line 4, and this is the instruction. No, hold on a sec. Line 3, sorry. This is the instruction format. Okay, so 4 to binary is 100, and W is 1 because this is 16 bits. Now first goes the source register CX. CX is 001, then the target register DX. DX is 010. Okay, so this is hexadecimal. Okay, this is binary, and this is binary, and eventually we have 09CA. So let's see if this is the case. 09CA, this is the case, great. And now we want to bitwise OR the value for this 2 bytes, this word, with whatever we have in BX. So let's say BX. So this is the opcode. Okay, line 4, and this is the instruction format. So 4 is 100, here 1 because BX is 16-bit. Okay, the register is BX 011, and the address is F001, just like before. Okay, so this is hexadecimal, this is binary, this is binary, this is binary, this is hexadecimal, and it turns to 091 E F001. Let's check this out. All right, 091 E F001, which is correct. Great. And now bitwise OR DH with byte in memory with this one. So this is gonna be this is the opcode, all right, and the format is the same as before. Copy and paste. So DH is 001. DH is 110. DH is 110. The address is F001. 5 in binary would be 101, and W is 0 because DH is 8-bit. So this is hexadecimal. This is binary. This is binary. This is binary, and this is hexadecimal. And eventually we have 0A 36 F001. Check it out. 0A36 F001, which is correct. Okay. So now the very last but not least is the XOR instruction. So XOR, let's start with a special case. So 35, if the special opcode, if we want to XOR AX with the constant, so 5588. Okay, 355588, which is the case. Great. So now XOR DH with a constant, with immediate data. So the opcode, and then the instruction format. Okay, question mark for this operation is XOR 110. All right. Okay. So the register is DH, which is probably 110 as well. Okay, 110, 000, and 0. Hexadecimal, binary, 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 and 05. Hexadecimal, 80F605. Let's check this out. 80F605, which is correct. Okay, let's move further on. So XOR DX and CX. So here is the opcode. Okay, and now the instruction pointer, now the instruction format is here. Okay, W is 1 because DX, CX, and CX are 16-bit. First goes CX, cx is 001 and dx is 010. Okay, 010. This is hex, this is binary, this is binary, this is binary, and we have 31CA. All right, 31CA, which is the case. Great. And XORing this word with BX. So here, same opcode, but a different format. So here is the format. Copy, paste. W is 1 because BX is 16-bit, so this is hexadecimal. The register is 011, and address F001. All right. Binary. This is binary. This is binary. This is hexadecimal. So 311 E F001. Let's check this out. 311 E F001, which is correct. Great. And the very last. So XOR. This is the opcode. We have the same instruction format here. So DH is 110, and F001 is the address, hexadecimal, 001, 0, because DH is 8-bit. So this is hex. This is binary. This is binary. This is binary. All right. So 3, 2, 3, 6, F001, and 3, 2, 3, 6, F001. And this is pretty much all about it, guys. So now let me uncomment all the instructions and assemble them all, just to give you some material for practice. Okay, so you know, like I've been talking about writing in machine codes under my operating system GameOS, which has the hex editor as the only development environment. So now with this, I was just testing this table. I've handcrafted it on my own from the different sources, and by making these videos on hand assembling the instructions, I was just verifying my own self of like whether I did everything properly or not. It should be, generally it should be okay. So the rest of instructions we have are trivial because it's just like like a lookup table, so nothing special to cover here really. So I will then put this into the GameOS to be able to display this on screen. So we don't need to have any like documentation dependencies, but just type a command to see this opcodes, and then handcraft opcode here in the command line, and then the value that will come up eventually with just to put to like just to put that value to the hex editor and run the code. That's pretty much it. So that's how we can develop in machine codes using by doing the hand assembling. So we don't have, if we don't have an assembler, we can do this kind of like by hands, and also have the ASCII characters table to be able to define the strings if we need that. So I hope it's clear, guys. So check out my GameOS if you're interested, and this is it from my side. Thanks for watching. Until next time, and take care.